All right, this is the solution guide for the mole conversion worksheet. So we're converting moles and molecules and grams, all that stuff. All right, so first one, 0.89 moles of calcium chloride, and we're going to mass. So first thing, let's see, we need to put on here 0.89 moles of calcium chloride. Since we're going from moles to grams, what we need to know is the molar mass. We want the moles to go away, so they need to go on the bottom. It's always 1 mole. And if I add up calcium chloride, calcium's 40.08. There are 2 chlorines, each at 35.45. And let's see. Multiply and then sum. That's going to be 110.98 grams of calcium chloride. Moles cancel. 0.89 times 110.98. Sig figs, you're going to be limited to 2 because of those 2. So it's going to be 98.77. You're going to round that up to 99 grams of calcium chloride. Okay, this next one, 158.1 grams of lead 2 sulfate into moles. So start with what we know, 158.1 grams lead 2 sulfate. Okay. Once again, grams and moles, we need to know molar mass. This time moles are going to be on the top. And as always, it's 1 mole. And so if I add these together, I think lead's 207.2, sulfur's 32.06. There are 4 oxygens each at 16 each. So if you multiply and sum, I think that ends up being 303.26 grams. Grams cancel, so I'm going to take the 158 and I'm going to divide by 303.26. You're going to have 4 sig figs because of the 4 listed there, so it should be 0.5213 moles of lead 2 sulfate. Next one, 1.112 moles of hydrofluoric acid to grams. So start with what we know, 1.112 moles of HF. Okay, and once again, moles and grams are using molar mass. We want the moles to go on bottom, so they cancel. It's always 1 mole. Okay, and let's see, hydrogen's 1.01, and fluorine looks like 19, so that should be 20.01 as its molar mass. 1.112 times 20.01, and you should get, with 4 sig figs, 22.25 grams of hydrofluoric acid. 4 sig figs because of those 4. Okay, 362.8 grams of pentane to moles. So, let's see, start with what we know, 362.8 grams, and pentane C5H12. Okay, and once again, grams and moles is molar mass. Moles are on top this time. Always 1 mole, and so I have to add up their masses. There are 5 carbons, each at 12.01. Looks like there are 12 hydrogens, each at 1.01. So if I multiply, and sum, this ends up being 72.17 grams. Grams cancel. I'm going to divide 362 by 72. When I do so, with sig figs, you should get 5.027 moles of pentane. Okay, this is moles and grams once again, so 0.159 moles of silicon dioxide. Moles need to go on bottom. As always, it's 1 mole. I need to put the grams on top, and so let's see here. Silicon looks like it's 28.09. There are 2 oxygens each at 16. So if I multiply and then sum, this ends up being 60.09 grams. I'm going to multiply 0.159 times 60.09. And with sig figs, you should have 3. It ends up being 9.55 grams of silicon dioxide. Next one, we have 12.35 grams of butyric acid. This is the stuff, butyric acid, that's what rotten milk smells like. That's from butyric acid. And so let's see here. Butyric acid is going to be C4H8O2. Okay. And grams to moles, once again, it's a molar mass. So 1 mole butyric acid, and I need to add these up. There are 4 carbons, each at 12.01. 8 hydrogens, each at 1.01. 2 oxygens, each at 16. So if I multiply, and then sum all those together, it ends up being 88.12. Grams cancel. This one I'm going to divide. 12.35 divided by 88. When I do so, I'm going to have 4 sig figs, so it's going to be 0.1401 moles of the butyric acid. Now you guys might think, man, we're doing a bunch of grams and moles and grams. Well, the reason why, they're the most useful ones. We don't deal with the atoms and molecules a whole lot. There are a couple down here at the bottom, but moles and atoms or moles to like molecules, not as useful as a calculation. Moles and grams we're going to do all the time. That's why we're practicing that one the most. Okay, the next one, 3.66 moles of nitrogen. There is a little twist to this one. So let's start with what we know. 3.66 moles of nitrogen. You guys have to remember nitrogen is Brinkelhoff, right? Okay, so it's diatomic. So I need molar mass of this. So moles need to go on the bottom. The key is, guys, it's N2, all right? It's not 14.01 because there's 2 of them. It's 28.02, right? So pay attention to that when you have diatomics. If you're ever doing molar mass of a diatomic, it's twice of what the periodic table says because there are 2 in the molecule, all right? So moles cancel. I'm going to take 3.66 times 28.02. With 3 sig figs, you should get 103 grams of nitrogen. Okay, next one. Let's see. We have 66.38 grams of potassium permanganate, and we want to find out how many moles that is. So once again, we need molar mass. Moles are going to go on top. Let's see. Potassium's 39.10. And let's see, manganese, I think, is 54.94, and 4 oxygens, each at 16. So if I multiply and then sum those, it should be 158.04 grams. Grams cancel. Divide. The number of sig figs I'm going to have is going to be 4. So you have to add a couple of zeros on here because I think it came out to be exact. So you have to add those zeros for sig figs. Moles of potassium permanganate, 0.4200. Okay, these last couple, you really didn't even need to know what the substances were because it didn't deal anything with mass, because these were both moles to atoms or moles to formula units, which is the same thing as saying really molecules. So it could have been anything at this point because it doesn't use the molar mass. We're just simply using the Avogadro's number for the relationship. So this could have been anything, but we'll say moles of selenium. Since we're going from moles to atoms, we use Avogadro's number. For every 1 mole of selenium or anything, there are 6.02 times 10 to the 23rd atoms. Moles cancel. I'm going to multiply across 0.59 times 6.02 EE23. When you do that, 2 sig figs, 3.6 times 10 to the 23rd atoms of selenium. Last one, formula units. That's the same thing as saying like molecules. Okay, so let's see. We're starting out with what we know. 6.80 times 10 to the 24th. I'm going to say formula units of barium nitrate. You didn't even really have to write the formula, but because it would work the same for anything, but regardless. I know that there is 1 mole for every 6.02 times 10 to the 23rd formula units. Formula units cancel. I'm going to divide 6.80 EE24 by 6.02 EE23. You should have 3 sig figs in your answer. 11.3 moles. Well, my pen decided to stop working there in the last second. There, 11.3 moles of barium nitrate.